Welcome to May's Leetcode Challenge. Today's problem is maximum gap. Given an integer array nums, return the maximum difference between two successive elements in its sorted form. If the array contains less than two elements, return 0. You must write an algorithm that runs in linear time and uses linear extra space. So this is the key thing that makes it very difficult. Let's just say that we didn't care about that. How would we solve this? Well, it'd be pretty simple, right? Let's first get the length of our nums, and the very first thing we want to check to see is if n is what, less than or equal to 2, then wait, let's see here. Okay, less than 2, I mean, then we just return 0. Otherwise, we want to sort our nums, right? We sort it, and then we're just going to find out our answer by iterating down for I in range of 1 through n. Just get the output to equal the output is equal to the max of output, and the absolute value of nums I minus 1 minus nums I, and then we can just return our output. So that would be the simple way. But this technically is not O of n time. It's going to be n log n because of this sort, right? This actually does get accepted if you submit it, but it really shouldn't count because we want to do this in linear time. So how can we do this in linear time? Well, okay, we have that. We know the fact that these are all integers, right? And there's only one sorting algorithm that I know of that is able to do linear time sorting for integers, which is bucket sorting. Now, bucket sorting is pretty good when you have a limited number of numbers that we can use, but here we can have numbers from 0 to like 10 to the 9th power. What is that, like 100 million? So that's not very good for bucket sorting, because normally you create an array with however many different types of numbers we have, but we don't really want to have an array with 100 million indexes. So what we can do instead is, rather than having each individual number be an index inside of an array, we will do something where we find the range of our numbers. We'll get the low and the high, and we're going to bucket all our numbers into n minus 1 buckets. Now what that means is, depending on how our list is distributed, say that we have like 1, 2, 3 to like 100 or something like that, 1 or 1 maybe, what this will do is bucket it by, we first find the range, which is going to be what the high minus the low, that's going to be 100, and we're going to multiply whatever number we find. We're going to first find the absolute difference from the low, which is kind of telling us like where is it in this distribution. Then we're going to multiply it by the number of numbers that we have, and then divide it by the range. And what that's going to do is kind of put these into buckets. So here, like 1, 2, 3 will go into one bucket, while 101 goes into like another bucket, and here we'll probably have 2 empty buckets here, something like that, and minus 1, so that'd be 1, 2, 3, 4, so it'd be like this, something like this probably. Now what this means actually is all we need to do is find the gap difference here, and we can skip the ones that have no numbers inside. We'll just get the difference between the max number inside of this bucket with the next successive bucket, get the minimum one between that, and here we can see that's going to be 3 of 101. Now, don't ask me why this works. It's pretty complicated how exactly it works. It has something to do with the pigeonhole principle. But essentially, like if it was evenly distributed, like what would happen is all these numbers would get put into like different buckets, like on its own. So the gap between these two is always going to be like, it's never going to be within here. Like if we subtract one bucket here, one of these gets put into like here like this. The max difference is always going to be between buckets, not within the bucket itself. Okay, so don't read too deeply in that, like just know that's how it works. So what we're going to have to do here is calculate the low and the high. We'll call it low and high, and we'll get the min of the nums and the max of the nums. Now next we'll have our bucket, which is called B, and we'll have a default dictionary with list, and the key is going to be the bucket numbers from 0 to n minus 1. Okay, so now let's populate our bucket for, let's see, I'll say for n in nums. We are going to calculate the index, which is going to be let's see, the absolute value of low minus num We're going to multiply that by n minus 1. Okay, and then we're going to divide this by the low or high minus low. Okay, and this is going to be the index value. Now there is one exception. If this num is equal to the high, then we should just make the index value equal to n minus 1. Because we're just going to make the highest value put into that last bucket there. Otherwise, we want to figure out which bucket it can go to. So this would be it. Now let's add that to our bucket now. So b of index number, append whatever this number is. Okay, so now that we have this, what do we need to do? Let's create a separate list. We'll call it temp. And we'll name it buckets instead. And instead of the default dict, here we're going to skip any empty buckets. Okay, so let's see, for I in range of, wait, am I doing this right? Buckets. For I in range of n. I apologize here, I'm brain farting. It's high for I minus. I guess it's for I in range of n minus 1. No, it's for I of range of n. We'll say if there's a v of I, then let's append to our buckets a tuple of the max or the min of b of I, and then the max of b of I. Okay, so now we should have populated our buckets, and now all we need to do is go through this, but instead of I through n, we're going to say for I through the length, I to the range of 1 to the length of buckets, we're going to find, rather than nums, we're going to get buckets, I minus 1, and get the very last one here, which is going to be the max. Same thing here, buckets, but instead of the last one, we're going to get the first one, which is going to be the min. Finally return the output, and that should be it. So let's make sure this works. Okay, it looks like it's working. And accepted. There we go. Time complexity is O of n, and we also use O of n space. Now, if this is confusing you, don't worry, you're not alone. It's pretty confusing, the fact that this works. But really, if you just get the principles and kind of learn about what bucket sorting is, I think that's good enough. Really, these problems, sometimes it's just like very unlikely you're going to come up with it yourself. You're just going to have to memorize these and hopefully apply it next time. So, alright, thanks for watching my channel. Remember, do not trust me, I know nothing.